Started with our brand new unit on triangles. Now it's not going to be triangles that you've maybe seen in the past with stuff like Pythagorean theorem and maybe some SOHCAHTOA stuff or even area equals base times height. We're going to use trigonometry to solve these triangles. So we can use the law of sines to find missing angles and missing lengths. We can use law of cosines to find missing angles and missing lengths, or we can use the area of a triangle formula, which I'll show you later on, to find the area of a triangle. So in the past, you've worked with mostly right triangles. This stuff will work with any kind of triangles. So that's what we're going to do, and we're going to start with the law of sines. All right, so with the law of sines, when is it appropriate to use it? The way that I figure out when to use law of sines is when you have a pair I'm going to say a matching angle and side pair. So anytime you have an angle along with its opposite side, so if I just draw a little triangle over here, let's say I have this angle, the opposite side is this one. If you have that pair, you can use that pair to find basically any other piece of information in the triangle. Let's say you were given this angle over here. Then you better have that pair. And then you can use that pair to find anything else in the triangle. And likewise, if you are given this angle and this side, the matching side, the one opposite of it, then you can use that to find any other piece of information. So as long as you have an angle with its matching side, the one opposite of it, then you can use the law of sines. There's going to be a formula for this. This is again in the formula booklet if you want, but it's just A matches with the sine of angle A. Usually sides are lowercase and angles are uppercase letters. Equals B over sine capital B. And then it also extends into equals C over sine C. That doesn't really matter too much. So the first example says to find the missing length in the triangle below. So first off, let's see why we're using the law of sines. We are given this angle, and the side that's opposite to it is this side over here. So that angle corresponds to that side. And we're going to use that pair to help us find this other pair. So let's go ahead and set this up. We have 14.3 matches with the sine of 38 degrees. And likewise, we have x matches with the sine of 113 degrees. So you notice that we're using the pair that was given to us. This 14.3 matches with this angle here, sine of 38. And we're going to use that to help us find the missing information. So now, if I want to solve for x, it's actually pretty easy here. All you have to do is multiply both sides by the sine of 113. So multiply by the sine of 113 on both sides. Sorry, that got scrunched in a little bit. And by doing that, those go away. Now to type this in your calculator, you can go up into Desmos. So here's Desmos. Make sure you are in degree mode. So on the bottom here, you see where it says radians and degrees. Make sure you tap on degree mode, because all of these degrees, or the angles that we're putting in, are given to you in degrees. They might be given to you in radians at some point, but for now we're sticking with degrees just because it's easier to visualize. So with that one, you could type in the sine of 113. So the sine, you're going to go to functions, and you can see the sine of 113. Then you're going to multiply it by 14.3. And then it all gets divided by the sine of 38. So there's function sine of 38. And when you do that, it gives you 21.4 or so. So we can go over to Notability, and we get x equals 21.4. And the units for that is going to be meters. And it's always a good idea when you're done to just double check the reasonableness of your answer. So if this length looks like it's about 14.3, does that seem like it could be about 21.4? Yeah, it has to be longer than 14.3. Usually, another way that you can check your answer is, at least the reasonableness of it, the bigger angles will match with longer side lengths. So you got this 38 degrees matches with a smaller side length. The bigger the angle gets, you better have a bigger answer. So 113 is bigger, and so you do get a bigger answer, 21.4. Try the next two on your own. So you're going to go ahead and pause this video, and when you are all done and you're confident with it, come on back and I will reveal the answers to you. All right, I'm giving you one of them, and hopefully you were able to set that up correctly. Here's the pair that you were given. 28 matches with the sine of 73 degrees, and you use that to find the other pair. So x matches with sine of 76 degrees. If you just solve it, you get 28.4 centimeters. Now the other one, maybe I tricked you a little bit on this one. So we do have this pair, 92 degrees matches with 36. Let's go ahead and write that out. 36 matches with the sine of 92 degrees. But now if I'm trying to find this this side over here, it matches with this angle way over here, which we don't have. However, hopefully you remember that within a triangle, you always have 180 degrees. So if we have 180 degrees, and we know that the other ones are 92 and 61, it gives us the remaining degrees, so I know that this angle over here is going to be 27 degrees. So now knowing that that's 27 degrees, I can use that to find the length. So x matches with sine of 27 degrees. And you can go ahead and solve that by multiplying both sides by sine of 27. I won't do that for you. You can do that on your own. Now we're going to switch gears a little bit. You can also use the law of sines to find a missing angle. So previously we just used it to find a side. Let's use it to find an angle. So we are once again going to be using our pair. So here's our pair that's given to us. 28.5 centimeters matches with 108 degrees. Now I'm going to switch the formula around. Instead of having A matches with sine A equals B over sine B, you can flip this upside down. Sine A matches with A, and sine B matches with B. And the reason that I'm doing that is just going to be because it puts the variable on the top for you. So it doesn't really matter. You can solve it both ways. I just like having the variable on top. So with that being said, let's go ahead and set it up. We have the sine of 108 degrees matches with 28.5 centimeters. And we put equals the sine of x degrees. We don't know what that degree is, but it matches with 18.1. And hopefully you're okay with that. Here's the two pairs that we're looking at. So now what I want to do is I want to multiply both sides by 18.1. 18.1. So now I'm going to go on to Desmos, and I'm going to type this in. So 18.1 times sine of 108. 18.1 times sine of 108. And then it has to get divided by 28.5. And you'll notice we get 0.604 and so on. So I'm going to go back to Notability. That's about 0.604 equals sine of x. But I don't want sine of x, I just want x. So if you think back to algebra, to get rid of an addition, you do the opposite. You do subtraction. To get rid of multiply, you have to divide. To get rid of a squared, you have to square root it. To get rid of an exponential function, you take the log. You probably don't remember that one so well. But to get rid of a sign, we have sine of x. I don't want sine of x. I want to get rid of the sign. We can do inverse sine. So technically what you're doing is you're doing inverse sine of sine of x, and then the inverse sine on both sides goes away. But basically all we have to do is inverse sine of that 0.604. So let's go over to Desmos, and we can do functions, the sign with a -1. Oh, I don't want it there. We want the sign of -1, and then I'll put that 0.604 in there, and it gives us approximately 37.2 degrees. So we'll go back over here, and that's 37.2 degrees. If this were me typing this all in one line on a calculator, what I would do first is I would actually do inverse sine, and then I would type this entire thing in, so I could do it all within one line on the calculator. If you like to take it step by step like we just did it here, that's fine as well. So go ahead and try. This one might require a little bit more practice, so go ahead and try the next two on your own, and then when you are done, come on back for the big reveal. Okay, go ahead and hit pause. Okay, welcome back. Hopefully the first one wasn't too much of a challenge for you. We use this pair right here. So we set sine of 37 matches with 28 equals the sine of x matching with 45. And when you solve that one, you end up getting about 75.3 degrees. It's always a good idea to check the reasonableness with the picture. I draw these pictures so they're bound to be off by a little bit, but does that angle look like it could be about 75 degrees? Yeah, it seems reasonable. If you get an answer like 12 degrees, you probably did something wrong, because I try my best to make these pictures somewhat accurate for you. And for the next one, again, maybe I tricked you on this one. We're using the pair that's given. Sine of 136 matches with 32. But now the only other information, tongue's getting tied, the only other information is this 15, which you can use to find this angle. So we match up sine of 136 is 32, sine of x matches with 15. And by solving that, we end up getting x equals approximately 19 degrees. However, that's not the angle that I was asking for. So I do know that this is now 19 degrees, but remember, a triangle has 180 degrees in it. So if you want to find this last angle, the one that was actually being asked for, and then you can just subtract from 180. And if you do that, we end up with the missing angle is equal to 25 degrees. So be careful of what they're asking for. Sometimes you might have to have another step in between. But that's the process for using the law of sines to find both a side and an angle. So just make sure you use that pair, use the pair to find some missing information in the other pair. And that's it. Stay tuned for next week when we learn about the law of cosines. See you later. Bye.